This is our first lesson in our unit on circular motion, and despite the title, we are not actually going to look at circular motion at all. We're instead going to look at how we measure angles. So there's another unit for measuring angles called radians, rather than our usual degrees. So radians are commonly used in physics and maths and engineering, and they offer a more useful and an easier method for dealing with angles. While it's easier in the long run, there is the difficulty in the short term of figuring out how degrees and radians relate to one another and what radians are in fact. So I'm going to start with a couple of the conversions. So 360 degrees to a full circle, that is 2 pi in radians, or rads, or AD. You can simplify that down to 180 degrees is pi radians, and that's typically the one that you'll remember. And then if you want to simplify it down further, 1 degree will be pi over 180 radians. So they're useful things to remember, and they're good ones to have in your head. Like I said, especially this one, and from there you'll be able to work as you need to. So let's take a closer look at radians themselves then. So radians are calculated using arc length, which is the length along the arc, divided by the radius. So the more arc length you have, the bigger an angle you'll have. If you have half a circle, you'll have pi radians. If you have a full circle, you will have 2 pi radians, which will be 360 degrees. And this symbol here, theta, is what we use to represent our angles. When we're defining radians, it's useful to figure out what 1 radian is. And the easiest way for doing this is to take the arc length the same as the radius. So when your arc length equals your radius, you will have 1 radian as your angle. So 1 radian is when S equals R. So theta then will be in the formula S over R, which would equal 1. In degrees, that's 57.3 degrees, but we're not too worried about that. If the arc length was double the radius, then it will be 2 radians. If it was treble, it would be 3 radians, and so on. Half would give you half. So that's the relationship for radians with degrees. So we will, from here on, we will measure only in radians. You won't be given degrees, and if you are given degrees, you'll need to convert into radians. Again, it's not much more difficult than thinking of your 2 different units of measurements of degrees and degrees Celsius and degrees Fahrenheit, but we will be using radians moving forward. If you want to use radians on your calculator, here are the steps. So first off, you press menu, then you select radians, and that's all there is to it. But remember to switch back when necessary. So often you'll be working with degrees, often you'll be working with radians, so it's important to make sure that your calculator is set in the correct mode, because if not, all your calculations will be off. So radians are a useful unit as they allow us to work with lengths which are commonly known rather than angles which are not, and it will be difficult to determine. So when we do look at circular motion, it will be much easier to see how far something has traveled in a circle, so the distance it's moved, rather than if we could figure out the angle it made while moving. So if we just deal with the distance traveled and we know the radius, we'll be able to deal with more of our calculations, and it's much more normal to have those kind of measurements when we're dealing with physics.